You come from TypeScript, so Python's type hints feel like home. That familiarity is dangerous. In Python, the types you carefully write are not checked when your code runs. At all. Let's take a function that trusts them the way TypeScript would and rebuild it the way a Python pro models data. It takes some incoming data and builds a user. It looks typed and it looks safe. It is neither. Watch. Look at the annotations. Data is a dictionary, it returns a dictionary. In TypeScript, the compiler enforces these and refuses to build if you violate them. In Python, these annotations are pure metadata. At runtime, they do absolutely nothing. Call this function with the number 123, and Python doesn't even glance at the signature. It happily runs until it crashes deeper in, on a confusing error, far from the real mistake. This is the single biggest misconception a TypeScript developer carries into Python, that the hints protect you. On their own, they don't. What therefore is static analysis? A separate tool, MyPy or PyWrite, which powers your editor, reads them and flags mismatches before you ever run the code. So hints are real and worth writing, but only if you actually run the checker, in your editor and crucially in CI as a required check. The principle: type hints are documentation and tooling, never a runtime guarantee. The intuition: if a type mismatch would actually hurt, a checker must run because the interpreter will never catch it for you. Now the shape of the data itself. We build the user as a bare dictionary, keys typed in by hand. This is the JavaScript object habit, and it quietly costs you everything the language could give you. No autocomplete on the fields. A typo in a key is a silent runtime bug, not an editor error. And no real type, it's just dictionary everywhere. The Pythonic move is a data class. You declare the fields once with their types, and you get a real class. A proper constructor, equality that compares by value, a readable printout, and critically, editor autocomplete and checker coverage on every field. .name instead of bracket quote name quote. The principle: model data with a class, not a dictionary. Reach for a data class the moment a dictionary is standing in for an object. The intuition: if you're writing the same string keys into a dictionary in more than one place, that's a data class waiting to happen. But there's a gap the data class doesn't close, and it's the one that bites in production. That incoming data came from outside. An API, a request body, a config file. It's untrusted. And a data class, exactly like the hints, does not validate at runtime. Hand it the wrong types or missing fields, and it cheerfully builds a broken object that explodes later, somewhere else. So here's the division of labor a Python pro internalizes. Use a data class for data you already trust, internal, already validated. But at the boundary, where untrusted data enters, use Pydantic. A Pydantic model looks almost identical to a data class, but it actually parses and validates at runtime. Wrong type, it coerces or raises. Missing required field, it raises a precise validation error, telling you exactly what's wrong, right at the edge where you can handle it. This is the one place Python gives you TypeScript grade guarantees because you asked for them explicitly. The principle: data class for trusted internal models, Pydantic at every untrusted boundary. The intuition: the moment data crosses into your program from the outside, it goes through a Pydantic model. No exceptions. Watch it guard the boundary. We hand the Pydantic model a dictionary with a name, but no age. It checks the fields. Name is fine, but age is missing. So instead of quietly building a broken object, it rejects the data on the spot, raising a validation error that names exactly what's wrong. Age is required. Bad input never makes it in. Same intent, 3 levels up. The types are now checked by your tools before you ship. The user is a real modeled object, not a bag of strings. And untrusted input is validated the instant it arrives, failing loudly and precisely, instead of silently corrupting your state. That is how a Python pro thinks about types, not as a compiler that isn't there, but as tooling plus explicit validation, exactly where it matters. TypeScript hands you safety by default. Python hands you the tools and lets you place the safety deliberately. Learn where to put it, and you get the best of both. Subscribe to Code Craft. One more deep dive to go.